right, thank you all for coming to our presentation. I'm Sean,
And I'm Ben.
and this is our feasibility study for vertical farming in Western Massachusetts.
So our project was to investigate the feasibility of investing in a vertical farming operation here in Western Massachusetts by leveraging the old abandoned buildings that we have in the area and to use hydroponics and LED lighting.
Just a little background on what vertical farming is. Vertical farming is, rather than being on acres of farmland growing crops, vertical farming is a way to stack those that space vertically so that you can grow crops in a more condensed space.
So in terms of growing indoors, so for the past decade or so, LED technology has been decreasing in costs, which make the capital investment a little bit more attractive. And hydroponics too has come a long way. And hydroponics uses, it's not soil based, so it uses a nutrient solution where the plants are suspended above the water and the roots will grow down into the water solution. So in terms of the first step, we had to just look at the benefits here in Western Massachusetts. So there's two main benefits in terms of like tax incentives. So the state offers like a investment tax credit, and in terms of local tax incentives, it's mainly just property tax based on how many jobs you offer at the local area. And the table on your right is just a sample cost for all the lease pricing or just flat out buying of buildings per square foot.
Once we found the most appropriate location, we want to kind of configure a sort of concept to get the idea of how we would use that space. What you're looking at up here on the left is a ground, we don't want to say layout, but more of a model that represents a 1,000 square foot area. We want to emphasize, especially in the green areas here, that these actually are the only areas that we can actually grow crops. We were able to do vertical farming indoors. You can see here that the gray space is more utilized for walking through aisles, putting equipment down, and using those within that area. And then over here, this is how a shelf would look. This is what the green areas on the ground layout would consist of. We have 3 shelves here, and then of course the blue here is for the nutrient-based water. The green here is for the plants, and these are the LED lights on the top parts of the shelves shining down on the crops.
So in terms of capital expenses and operating costs, we calculated pretty much everything for capital cost per square foot, and we included like the renovation costs like an HVAC system, the LED lighting capital investment, the plant trays and reservoirs, and we came up with a total of $85,000 in capital investment. And in terms of operating costs, monthly operating costs, electricity's $2,500, labor's $2,400, and those two combined actually make up 80% of the operating costs per month.
Once we found out the cost for the building itself and the equipment that's being used, we wanted to find not the optimal but most suitable crops based on the location and what we can grow in a certain amount of time. We picked these 3 based on 3 or 4 different key factors, mostly being how easy they are to grow, how high the demand is, and what the price would be if we were to put it into the market. So this is the revenue analysis here. You can see that we have taken the amount of pounds we could yield per square foot if we were to vertically farm these crops. From there, we took the market pounds per the dollar per pound price. We want to convert that into dollars per square foot. And in relation to the amount that we could yield per month or so, we want to get a final monthly revenue for each crop.
So the final results was that none of the monthly revenues exceeded the monthly expenses. And even considering a rate of return of 15%, which is what most businesses would look for, you need a monthly revenue of $7,500 to be an attractive option, and that doubles even our highest revenue at the current state. So we decided to change some assumptions around. So for one assumption, we said, what would it look like if we reduced labor and electricity costs by 50%? And the resulting expense would still be $3,600, but we'd still need to increase our crop price by 53% for lettuce, 230% for strawberries, etc. And even if we combine both capital investment reduction by 50% and operating costs by 50%, we still would need to increase our crop price by 32%. It might be feasible if you charged a pretty high premium, but it would just reduce demand at that point. So that's what we found. Any questions?
Well, I like your analysis, made it very, very well presented. What if you were to move your plant to like, Greens, that's probably not a good choice, but someplace that's almost Arctic, but that there's still enough people, would the increase in prices of going to such a desolate area where people still have demand, would that ever, do you think, justify this at the current time?
Well, it could definitely increase the demand probably.
I mean, in an isolated area.
I mean, basically, you're weighing transportation costs from other places, right?
Yeah.
I mean, the electricity cost is a
Oh,
major
yeah.
factor, so, I mean, if you're in a random area, that's probably still gonna be pretty high.
And also space, once you're in a remote area, it's less likely to be space. The idea was here, we're surrounded by empty warehouses.
Yeah,
Yeah.
okay.
Yeah.
Did you decide to use LED lights because they were cheap? Like, did you think about like for instance, just these lights here, like what that would have an effect on the actual growing of the plants we're doing?
Yeah, we did consider like HID lighting, but an LED light can still put out the same amount of light in terms of what it needs to grow with half the wattage. So it would just further reduce the operating costs.